Now that we understand what a basic subset is, we can learn how to count subsets using a very simple rule. In a set with n elements, there are 2 to the nth power subsets and 2 to the nth power minus 1 proper subsets. So the total number of subsets is given by 2 to the nth power. That is counting all of the proper subsets plus the set itself. Look at the note. It says every set is an improper subset of itself because every set is equal to itself. So when we calculate 2 to the nth power, it is also counting the set itself as one of the subsets. And the empty set is a proper subset of every set. So when we subtract 1, the one that we are subtracting here is the set itself. It is the only one that is an improper subset, or the only set that is equal to itself. So to count the number of subsets of a set that contains n elements, we evaluate 2 to the nth power, and the total number of proper subsets is 2 to the nth power minus 1. Let's try example 3. It says, list all the subsets of the set MATH. Now, before we get busy listing these subsets, let's use our formula to predict the number of subsets we should obtain. So based on our rule, we can say the prediction for the number of subsets, we can expect 2 to the 4th power. Notice I have 1, 2, 3, 4 elements here. So the exponent on the 2 that I use is 4. 2 to the 4th, which means not 2 times 4, but 2 times 2 times 2 times 2. 2 times 2 is 4. Multiply that by 2 to get 8. Multiply by another 2, we get 16 total subsets. And 2 to the 4th power minus 1, or 16 minus 1, which is 15 proper subsets. Now that we know what to expect, let's get busy listing the subsets. And let's begin with the proper subsets. So we'll start with the smaller ones and we'll work up to the improper subset. Now remember, the empty set is a proper subset of every set. So I'm going to start with the set that contains 0 elements, and I'm just going to draw that as a set of curly braces with no elements. So there's my first subset. Next, we could consider all of the one-letter subsets. So one possible subset would be the set containing the letter M, or the set containing the letter A. And we could do that for each of the individual letters of the original set. Now, let's list all of the 2-letter subsets. So one possible 2-letter subset is the set that contains M and A. Now, I'm going to try to do this systematically so I don't leave anything out. So I'm going to construct all of the 2-letter subsets that contain the letter M. So far, we have M and A. Next, I'll do M and T, then M and H. So those would be all of the 2-letter subsets that contain the letter M. Now, let's do all the 2-letter subsets that contain the letter A. Now, I don't want to construct the set AM because that would be equal to the set MA. Remember, if 2 sets have the same elements, then they are equal. So I'm going to move on and construct the set containing A and T, and finally A and H. Let's do the 2-letter subsets that contain T. Notice we have T and M together, we have T and A together, so the last 2-letter subset looks like T and H. How are your curly braces coming along? Is your hand trained to write those yet? Hopefully you're getting better as we go. Sometimes it takes a while to get comfortable writing those exactly. Let's continue with all of the 3-letter subsets. So one possibility would be M, A, and T. Sticking with M and A, we could do M, A, and H. Those are all of the three-letter subsets that contain the letter M. How about A, T, and H? Whoops, I think I missed one. How about M, T, and H? All right, let's see how many subsets we have so far. I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have identified all 15 of our proper subsets. Remember, a proper subset is smaller than the original set. So the sets that we have listed up to this point contain 0, 1, 2, or 3 elements. So there's only one more subset, and it's known as the improper subset. The improper subset is the set itself, M, A, T, and H. When we count that one, we have a total of 16 subsets. You can kind of understand why it's called an improper subset, because it is equal to the original set and doesn't really communicate the idea of being a smaller set within the larger set. Let's move on to example 4. Anna goes to Subway for lunch. She can choose from all, some, or none of the following vegetables for her sandwich: tomatoes, cucumbers, bell peppers, banana peppers, spinach, jalapenos, olives, and onions. You know, you've been into Subway. You know how many choices they have, right? How many different variations are possible? Well, Anna could go in and decide that she doesn't want any of those vegetables, right? She could say, I want the empty set, no vegetables at all. Or she could decide to get one vegetable, or maybe two, or maybe all of the above. So the question we're trying to answer here is, how many subsets can we form of this particular set? So let's figure out how many elements are in this set. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements. So N from our formula is 8. Therefore, we can expect 2 to the 8th total subsets. Now remember, that's not 2 times 8, that's 2 to the 8th power. So this means 2 multiplied by itself 8 times. Okay, we can do this a little bit at a time. 2 times 2 gives us 4. That one gives us a 4. So on and so forth. Then these two 4s multiply to give us 16. Those two multiply to give us 16. And 16 times 16 is 256. So there are 256 total variations. That includes the possibility that she chooses no vegetables at all for her sandwich, or also she chooses the improper subset, all of the vegetables, and then all of the combinations in between. So counting subsets allows us to predict the number of subsets without having to list them individually. 256 would have been a lot of subsets to list, but using the power of this formula, we can predict accurately how many subsets this particular set has. Now, for the rest of this section, you've learned everything new from this section. The other 2 lecture videos will consist of lots and lots of examples that review the symbols that we've learned up to this point, including the new symbols from this section.